Okay, in this video I just wanted to talk about the different formulas we have for a logarithm. So we had the three definitions of logarithms. We had a change of base formula, which is useful when you need to find a log base random number like log base 7, because we don't have a button in the calculator for log base 7, so we would need to use something like this to write it in terms of log, which there is a button in the calculator for. Now we have a couple of new rules. The first one is this one: log base a of 1 is always going to be 0. So if you think about it, if the base is a and the answer is 1, then we know what number should go in that exponent. A to what power spits out a 1. Anything to the 0 should be 1. It doesn't matter what the number a is. On the other hand, if I look at this guy, a to what power spits out the number a? Well, a to the first would spit out the number a. So log base a of a should be the number 1. Next up, we have a couple of weirder looking ones. This one is not too crazy though. Log base a of a to the r says a to what power spits out a to the r, and your answer is going to be r. So your answer is r. So you can think about this formula as saying that a logarithm and an exponential, if they have the same base, are going to kind of cancel each other out. So I shouldn't be saying that word cancel each other out, but that's effectively what's happening. A logarithm and an exponential, if they have the same base, are going to cross out and we'll have r. The same thing is actually true if you have the exponent and the logarithm in the opposite order. Exponent and logarithm should cancel out and just give you the number r. Okay, now we have some more interesting formulas. Let me just move that. I'm just going to show you what they all are. They're called the product property, the quotient property, and the power property. They seem like giant masses of gobbledygook. It turns out all these are somehow related to something we've seen before, though. Because we've seen a rule of exponents, it has a plus and a times in it. Specifically, a to the m times a to the n was a to the m plus n. So there was a rule of exponents that had multiplication and addition related. Here's a rule for logarithms, which are kind of like opposite logs or undoing logarithms, that also have a product and an addition associated with them. We just have to be careful with where exactly is the product and where is the plus. We couldn't say that log of x plus y was equal to log of x times log of y. That's not actually true. Big sad face. Okay, so we do have to be careful. The multiplication has to be on the inside. The plus has to be in between a log. So log plus log is product on the inside. So that's, I'm always going to think about these rules in terms of words. Log plus log, multiply the insides. Log minus log, you end up dividing the insides. And again, this is kind of associated with a rule of exponents that we've seen before. Specifically, let's see, the one with a quotient and a subtraction was this one. So these two rules are somehow related, same way these two rules are somehow related. I'm not going to get into why exactly or how exactly, it's not super important, but this logarithmic rule is essentially equivalent to this exponential rule. And then a power property is kind of a tweak of this rule. This rule says a log base a and an exponent base a cancel out. This one says, well, if you got different bases, they don't quite cancel out. You still have log base a of x, but the exponent r does kind of pop out front. So again, I'm going to think about all these rules in terms of words. Log plus log, multiply the insides. Log minus log, divide the insides. And an exponent on the inside is a product out front. So an exponent on the inside is a product out front. Okay, so these are all the rules. I'll show you in the next video how to use them.